What is a confined space? Any questions? The point is, there are a lot of different areas that may be considered a confined space. Sometimes they're identified with warning signs. Sometimes they're not. Some, like storage tanks, are kind of obvious. But others, like a trench, a diked area, or a pit, aren't. There are, however, a few approaches to identifying a confined space. One approach is to figure out if the airspace inside an area is confined or enclosed with unfavorable natural ventilation. Another is to look at how you have to get in and out of the area. If the entry and exit is limited, that is, if it uses hatches, manholes, has to be unbolted, or if you have to bend, crawl, or climb in, you could be dealing with a confined space. Another approach is to check with your supervisor, foreman, the unit operator, or whoever's in charge of the area you've got a question about. Generally, these areas aren't designed for you to be in continuously. And if you're not sure if some place is a confined space, stay away from it. Don't even stick your head in for a quick look. There are gases commonly found in confined spaces that can kill or knock you out in one breath. Now let's take some time now and talk about recognizing the hazardous gases and atmospheres found in confined spaces. Basically, you've got three types. One is combustible gases, vapors or dust. Another is toxic gases and vapors. A third type is an asphyxiating atmosphere where there's an oxygen deficiency. That's an atmosphere where there isn't enough oxygen for you to breathe. Now let's go over the combustible category first. Gases like methane and hydrogen sulfide are among the gases most commonly found. They're formed when organic matter decays. So that means areas near swamps, landfills, sewer lines, or treatment plants may have methane or hydrogen sulfide in the area. As a matter of fact, the area doesn't really have to be near the source of the gases. They can flow along underground utility lines or seep through the ground and into where you're working. That's how gases can spread. For example, from a sewer line into an electrical vault that's next to it, or from the earth into a trench. Combustible vapors in the air are usually formed from flammable chemicals. For example, the air inside a tank used to store oil, gasoline, or other chemicals may have vapors in it which could ignite even if it's empty. Or you might accidentally create similar vapors if you're working with flammable chemicals like solvents. Also, people pour or flush chemicals into sewers all the time, and chemicals may leak from underground tanks, all of which may end up where you've got to work. Combustible dusts are also a flammable hazard. You may already know of examples like coal dust or the dust in grain elevators. What you may not know is that if the amount of dust is high enough, other finely ground substances can ignite. What's a high enough concentration of dust to ignite? Some regulations say if you can't see past 5 feet, or in other words, if you can't see your feet, the amount of dust could be combustible. The next group of hazardous gases found in confined spaces are toxic gases and vapors. Some examples of these gases include carbon monoxide, and once again, hydrogen sulfide and chemical vapors. Carbon monoxide is dangerous because when you breathe it in, it gets in your bloodstream and keeps oxygen from reaching the rest of your body. It usually comes from the exhaust of gasoline-powered engines, you know, like the motors on your truck, car, pumps, or even on air blowers. The way to handle equipment like this is to keep it out of the confined space, or keep it downwind from the site. Hydrogen sulfide is also toxic, and it's especially nasty. One breath, even the smallest amount, like 1/10 of 1%, or 1,000 parts per million, is fatal. Fortunately, it does smell. Actually, it stinks like sulfur and rotten eggs, so it's easy to recognize. Unfortunately, it's so powerful it can knock out your sense of smell in one whiff. So you might smell it once, and then not notice it again until it's too late. Finally, chemical vapors can be toxic too. These vapors may be left over from substances stored inside tanks or vats, even though the substances have been removed. The last major category of hazardous atmospheres we'll cover is asphyxiating atmospheres, where there's an oxygen deficiency. The hazard here is that there isn't enough oxygen in the air to keep you alive. This can be caused by displacement. This is where something like the methane or carbon dioxide that naturally occurs in tunnels and sewers pushes out or displaces the oxygen in the air. Asphyxiating or oxygen-deficient atmospheres can also be created by consumption of the oxygen. This is usually caused by a chemical reaction like welding, or even if the space has a lot of rusting. What happens during these reactions is that the oxygen inside gets used up or consumed. If you run into this type of hazard, don't make it worse by trying to add pure oxygen. What's happened in some cases is that someone grabbed an oxygen cylinder and started putting in pure oxygen instead of breathing air. All they did was substitute a hazardous oxygen-deficient atmosphere for one that's over-enriched. What they found out was that in an over-enriched atmosphere, things like their hair and clothing caught fire very easily. What can you do to spot hazardous atmospheres that you usually can't see? Well, you don't use your eyes. You use this, known by different names such as an aspirator, sniffer, or gas detector. It samples the air and analyzes it for hazardous gases. We'll talk more about them later on. Right now, let's move on to the other category of hazards, physical hazards. These include physical conditions where the workspace is too noisy, or too dark, or too hot to work in safely. If noise is a problem, be sure to use an approved form of hearing protection. If it's too dark, you'll have to get work lights in there, but be careful. Regular lighting is an explosion hazard, and if there's a combustible atmosphere, there have been a number of fatalities where people tried using a regular light bulb, only to have the entire area blow up. Instead, it may be necessary to use explosion-proof lights, like this one. The same thing applies if it's too hot. If you need to bring a fan into the workspace to minimize heat stress, it may also have to be explosion-proof and possibly grounded to the space. Other physical hazards to keep an eye out for are those that can cause you to slip or fall. This occurs inside on slippery areas, or if you've got to use metal rungs to get in and out. You could be the first person in years to climb on them, and they could be loose. One quick check is to tap each one to be sure they're tight before you use them. And if you're using a ladder, be sure it's properly positioned and secured. Sloping walls and floors are another hazard that could lead to falls or worse. Some areas, like hoppers or air separators, may have sides that are slanted just enough for you to lose your footing. Not only could you fall, but you could slide right down into the next hazard, engulfment. Engulfment describes a simple situation. If you're engulfed by a substance, it means you're trapped in it and you won't get out. Now, while most people wouldn't walk on liquids, people working in confined spaces have walked out onto things like coal, gravel, grain, sawdust, you name it, because the surface looked solid. But they didn't realize that there were air pockets underneath that would give way. They got engulfed. They didn't get out. Piping or ductwork containing hazardous materials is another physical hazard to be aware of. To avoid accidental leaks or discharges, it may be safest to disconnect the lines. Locking and tagging out procedures may also be used, as well as blanking or blinding, or draining and venting the lines with a double block and bleed. Mechanical hazards, such as those from moving machinery, are the final type of physical hazard we'll cover. Basically, the concern here is with equipment that someone could get caught in, like conveyors or mechanical linkages. These hazards are usually controlled by physically disconnecting the drives or by lockout-tagout procedures.